Honors Algebra 2, Chapter 6, Section 6, the last section of the trimester. We're going to start with some review of solving. So if we're solving this for x, because we only have x squared, we don't have x squared and x, we only have that one term, we can solve this by square rooting. So we're going to add 3 to both sides. To solve for square rooting, we have to isolate the squared term first. So let's divide by -2. So x squared equals -18. And then we can square root both sides. And x here is plus or minus. And then we're going to have I, and then 3i root 2. And that'd be the simplified form of solution. And if you don't see how we're getting that, the square root of 18 is the same thing as the square root of 9 times 2. The square root of the negative is the I, and the square root of the 9 is a 3. So another problem here, this is still the square root. This is 3 times the square root. So to do this problem, we want to divide by 3. Then we get the square root of x minus 2 equals 2. Now, what would we do here to solve the problem? In the previous problem, we had the squared, and so we square rooted both sides to solve. Here, we have the square root, so we want to square both sides. And so if we square both sides, it's the opposite of square rooting. So we get x minus 2 equals 4. And we add 2 to both sides, so x is 6. So our goal is to solve radical equations. So anytime we have this radical equation, any root, cube root, square root, we want to first isolate the radical. That's the first step. So in this one right here, our radical is the cube root of 2x plus 6. We want to isolate that, so we need to get rid of the 3 coefficient. So we have the cube root of 2x plus 6 equals 3. Next one is going to raise each side to the inverse power. And I can show you how this works mathematically. So we have 2x plus 6 to the 1/3 power using our rational exponents. And so if we want to get rid of that rational exponent, we want to raise it to the inverse. The inverse of 1/3 is 3, or 3 to the first power, because 3 to the first times, or 3 over 1 times 1 over 3 is 1. So that undoes that exponent, so we just have an exponent of 1. We're going to raise both sides to the power of 3. When we do that, we end up with just the part underneath the radical sign, and it equals 3 cubed, or 27. Now it's not plus or minus here because we're doing the cube. We're doing a third power to both sides. If we square both sides, do an even power to both sides, then we get the plus or minus. Doing an odd power to both sides, we don't have the plus or minus. So now the last part is just solve for the variable, so we subtract 6 to both sides, and then divide by 2. So we get 10.5. You always check that by plugging that back into the original equation to make sure that we are true. So a few more examples here. For this one here, we need to isolate our square root. So we need to get rid of that 7 first, so let's subtract 7 to both sides. So negative square root x minus 4. Don't forget your negative sign. That's part of the root. So it's -13. So now we can multiply by negative to both sides, or divide both sides by -1, either way. So we get the square root of x minus 4 equals 13. Then we can do the opposite, so we want to square both sides. And so we get x minus 4 equals 13 squared is 1, you should know, 169. And then add 4, 173. Next one. A little more complicated, a few more operations in here. We can first subtract both sides by 7. So we get 8 on the right hand side. And then we can divide both sides by -2. Again, we're trying to isolate the radical portion, the root. So we have the cube root is going to equal -4. Now we need to get rid of that root. So the inverse of the cube root is raising things to the third power. Make sure you have a parenthesis around the -4. So you raise the negative and the number. Even though for this one, a negative to an odd exponent is still negative. And then 4 cubed is 64. Subtract 5 to both sides. So -59. And then divide by 2. So we have -59 halves, or -20. 29.5. Extraneous solutions. Extraneous solutions is when you raise both sides of an equation to the same power. Some solutions may be false. So there's solutions that are not actual solutions. So the algebra says there should be a solution, but it's not one of the solutions. So here, if we want to find x, we need to square both sides to get rid of the square root first. And when we square both sides here, the left-hand side is x minus 6. The right-hand side, we're creating more than we started with here. So it might be an extraneous solution. So x minus 8 squared, you have to FOIL this. So we get that trinomial. And so then we're going to use our quadratic knowledge here. So we need to put it in standard form. So we'll subtract x to both sides and add 6 to both sides. So 0 equals x squared minus 17x plus 70. So now we use our quadratic knowledge to solve this. And so factoring, we can look at factoring, and 10 to 7 looks like it might work. So x minus 7, x minus 10, negative 7 times negative 10 is 70, negative 7 plus negative 10 is negative 17. And so then we want to find our solution. So here x equals 7 and x equals 10. It looks like it worked out great. We did the algebra correct, but we might have extraneous solutions. When we square both sides here, and we have x on both sides, and you square that, that tends to be a red light for me that I have to check to make sure that I don't have extraneous solutions. So we need to put these solutions back in. So 7, let's put it back in here. 7 minus 6 equals 7 minus 8. And so I'm putting it back into the original equation and checking to make sure it's correct. So we get the square root of 1 equals negative 1. So we get 1 equals negative 1. That does not work. So already I see one. 7 is not a real solution. Let's put in 10. So the square root of 10 minus 6 equals 10 minus 8. You look adorable. That is super cute. That is.
It looked big, didn't it?
It did, but that's actually kind of small.
You are getting so big.
So this would be a square root of 4 equals 2, and 2 equals 2. So this one checks. So we only have one solution, x equals 10. The other one is extraneous. So last problem here, we can square both sides to get rid of the square root. And you do it on both sides, you actually get rid of both square roots. So x minus 3 equals 2x minus 7. So let's subtract x to both sides.
You see Kendall's dress?
So we can add 7 to both sides. So we get 4 equals x. So you can double check that by plugging that back in. So you have the square root of 4 minus 3 equals the square root of 2 times 4 minus 7. And you get the square root of 1 equals the square root of 1. And 1 equals 1, so that checks. So there's the solution. And so you can have square roots on both sides. If you square both sides, you'll get rid of the square root. And that is it for the trimester. Great job. Thanks for being a part of this.